All right, let's jump into it. Today we are talking about porting command line programs from Windows to Linux, and in a way it kind of includes porting from Linux to Windows. But in our case, we started off on Windows because that's what I had all the tools for, and I had a Windows machine, and it went, so now I have a Linux machine because Windows costs too much money. But in any case, so we're starting out here. We're going to talk to about porting the command line programs, and that primarily consists of four main tasks. We have to deal with the difference in #include files. We have to deal with different OS functions for doing things. In our case, it's getting the full path of a file from a file name. And then we have to deal with the various binary differences between Linux and Windows. One of the most annoying is that Linux likes to use // in file paths, and Windows uses backslashes in file paths. And in Linux, a backslash is an escape character. Same thing with the C language. And so the problem is, if you do a backslash in Linux, it ignores the next character or tries to interpret it as something special. So when we read from our files that may have it still in backslash mode because it originally was written in Windows, we just convert it on the fly. That's the idea. So getting through all of those, let's start at the start, clear that off, and we'll talk to our Windows, our #includes. So our original program had included windows.h and io.h, and those really don't have Linux equivalents, if you will. So in order to be able to switch this file between each mode, I created this #define in the build configuration under Windows, and in Linux it's not defined. So if this symbol is defined, then we do these two lines, and otherwise, if it's not defined, we do these other lines. And these other lines are all of the include files that are typical for Linux that we had missing bits, and then a couple of data types that don't, or rather, these two data types, the LP string and the D word, were defined in the windows.h, and since we're no longer using those, we just create a substitute for ours. And in doing this, we can just go from Windows in the build configuration for the Windows side. OS Windows is defined, and so it uses this. Otherwise, it uses the Linux defines, and we'll use this in a number of places throughout the code. So to begin with, this is the assembler for our EUP5108 compiler, our processor rather. And let's see, so this was the simpler one rather than the emulator. So once I get done showing you all this and get you the basics of it, and we'll jump into just the regular live stream conversion of the emulator, which is the main goal, is to see if that emulator is going to get better than 35 megahertz simulated speed. Because on the Windows machine, the same exact hardware and everything used to be a Windows machine, and it got 35 megahertz. So hopefully it'll go faster under Linux, but we shall see. So this #define OS Linux, or OS Windows, I made the mistake of doing _Windows_, which is the header guard for windows.h. And the header guard is what makes sure you don't re-include windows.h over and over again. And what that actually did was basically make nothing work inside windows.h. So I changed it to OS Windows. Be sure you don't accidentally reuse the same headers or header guard #defines in your code. So this is pretty straightforward. We'll just go ahead and highlight that, do Control Find, jump down to the next instance, and this is where you see we get a difference in OS functionality. We had a function called getFilePath from handle that had been previously defined under the Windows program rather, and we have to do something slightly different for Linux. It's not particularly complicated. I wasn't sure how to deal with this, and so this is one of those times where asking ChatGPT came in handy. I wasn't asking it to do some complicated new program or something like that. I just said, create me an example of finding the full path of a file from a file handle. This being file star, this is the file handle under the C standard library for reading and writing files off your system. So again, we just encapsulate the entire function in the #def Windows here, our OS Windows. So this version of it gets ignored when we're compiling in Linux, and instead we use this version, which, like I said, they're fairly similar. The main thing being that we needed to do this function readLink, which in the Windows version was get final path name by handle. So conveniently under Visual Studio or VS Code, we can just collapse that whole block of code, keep it out of the way. And then, like I said, this does the exact same thing the Windows version did, just uses the Linux functions to do it. And of course, because of the slashes, instead of looking for the last backslash in the file, we are looking for the last / in the file and getting rid of that so that our file path, both of these functions come back with the whole file name, full path, and the file name, and we don't really care about the file name, we just want the path. So by searching for the last slash in the path, we can replace that last slash with a 0, and that effectively terminates the string early for us. You'll notice I had to use double backslash in this version. And the reason I did double backslash is because the C language considers the first backslash to be a special character, or a special escape character. And the second backslash says essentially just do a backslash as one character. So that was the Windows side of it. Now then here's the Linux side, and let's get down to the next bit. The next bit of it is we have to change the way we change directories. So in Windows, it's set current directory A. The A means ASCII, meaning 1 byte per character, compared to wide character, which is 2 bytes per character. And then in Linux, it's just chdir, which is the way you would do change directory on the command line as well. So those are a couple of minor differences there. I think we do it again here at this stage. Difference between Windows and Linux. Then we get down to a little bit more complicated. This is 2 different ways to define or deal with the results from a string conversion. So what this is doing is it's reading in 2 characters. It's supposed to interpret those 2 characters as a hexadecimal number. The function strtol, or string to string to long, strtol. So string to long converts a string to a long integer, as it says there. And because I put in 16 for the base, it's saying it's expecting to convert it from hexadecimal. You could do the same thing with the decimal based. You would just put in 10 instead of 16. So 2 different ways of doing it. In the Windows world, there's this thing called errno, and it's just this global variable that gets set to some number when you do something incorrectly. So you intentionally set it to 0, you then make the function call, and then you check errno. And in the Linux world, there is no errno. Instead, you do the function, and if the end pointer is equal to the start pointer, then it couldn't convert it. Or the end pointer is not equal to 0. So either way, that tells it, when it's not equal to 0, it ran across an invalid character. And in other words, you're trying to convert hexadecimal, but you said ZZ instead of A through F, 0 through 9, A through F. So that's what that check is. And so really we're just actually redefining this whole if statement. For Linux, it's this, and for Windows, it's that. And those are the 5 primary changes that I had to make to the program. Not particularly complicated, but that's because it's a command line program and I'm not using any of the Windows to Windows. Hey, how's it doing? How you doing joining us today? Let's see. Hey there. Is that Raul?
Well, I hate butchering it.
I know, I hate butchering names too. Sorry about that. So we've got those three main changes that need to be made. And then after that, we have to deal with the difference in carriage returns and line feeds. So the Linux world said, we just need 1 byte at the end of a line of text. So at the end of this line of text in the file, it's using a character code 10, which is new line, and then it just, that's it. In the Windows world, it would say new line, but it would stay at the same column. So essentially it would just come down here. And so you'd say carriage return to get the cursor to come all the way to the end. So now you have 2 bytes in the DOS/Windows world, and only 1 byte in the Linux world. So that is actually handled in our readline function. Let's see. That's not readline, is it? Oh, no results. That's not good. Where is that function? It should be called readline. It should be at the very top of process. There it is. Oh, stupid case sensitivity. Hate that. Go to definition. All right, so here in our readline function, what we're doing is we're reading a character from the file, 1 character at a time, going through a loop, waiting for the end of the file. So this is not if not end of file on the file pointer. Our character that we read, we just get it from the file. Then we have to see what it is. So if it's a hashtag character, that's a comment. So we say we're in a comment. If we get to the carriage return, 13, if we see that, then really all we want to do is read the new line and get rid of it. So basically that's what we're doing here. We just say, oh, I read a 13, so I'm just going to read the next byte and throw it away, not do anything with it. And then if I happen to come up across a new line without the carriage return, then we're going to end the comment block and move on to the next line. Of course, it's read line, right? So one of these two tells you that you're at the end of the line. And since it's carriage return new line, I just use the new line as the final indicator. But without this, what was happening was it would come back and it would say, oh, new line, or carriage return is the first character in my next line. And then it would just go all off in the weeds. So that is the other big headache in Linux, which is carriage return. They call it just generically line endings. And that was pretty much it for the changes I made. Other than, of course, instead of Visual Studio, we're here in VS Code. So if we go ahead and run, you'll see down here in the terminal we've got a 32-byte section size. All of our symbol files are done. And that was pretty much all we had to do for the assembler. So that's pretty much it for that's pretty much it for me saying pretty much it, I think. But in any case, that's it for the assembler. And now we're going to switch over to the actual live action functionality of porting the emulator. And that is going to be slightly more difficult, I think, maybe. But you get to see it all live anyway. So feel free to hang out and we'll see how it goes from here. So let's see, a few kind of things that we had to do. So all of these things are new for, see, can I open these at the same time? Maybe. Let's see, we don't need that window. Put that off to one side. Come on, really? Can only have one VS Code running at a time, apparently. That's annoying. All right, so since we can only have one instance at a time, we will also bring up the File Explorer. Bring that to where I'm not staring up at the sky here. And let's see, we've got where is it? It is not under home. Oh no, there it is. Repos. So under the source, that was the assembler. Let's go look at the emulator. There's the emulator. And before we do this, we'll go back. I know we'll be going back and forth a bit, so not that one. Let's go to the assembler, which we already worked out. Copy the, oh, it's not shown. Let's see. Linux show. All right, so we want Linux to show us all the hidden files. Always hated the way Linux hid files from you with the dot name. Current folder menu. Let's see, open in terminal. Well, that's convenient. So, list files in a long format, or list all files. And you'll see we've got a .vs code folder. Change into that, and we have all sorts of stuff in there. So I'm going to copy the .vs code folder. No, I can't do that. I gotta, well, maybe I can do that. Let's see. And then we want to copy it up one level to another up one level to the, yep, emulator. Yep, emulator. And I think that's where I want to put it. So in theory, that'll copy the VS Code folder and all of its contents over to that other folder. Let's see. No. Yeah, at least it gave us a little hint. It said we need the -R. All right, now let's see if that worked. Nothing like working in command line mode, eh? Put that where everybody can see what I'm doing. Let's see, that's all the source. Show everything. Ah, we have a .vs code folder. How convenient. All right, that's going to be very useful once we open this folder in VS Code, right? So much for the File Explorer. We ended up back in the command line. So close that folder. File. Open folder. Repos. Source. Emulator. And that's the folder we want to open. Do you trust the authors? Yes, I trust the author. Mostly because it's me. All right, nice welcome page there. So this is a little bit more complicated. We've got way more code to compile here. And so let's see. Got all those. We're going to have to change those around a bit. You know, it's still referencing the old, maybe we don't have to change them too much because it's using these variable replacements. So dir name and base name and file and so forth. So we're not hard coding the names. Let's see. Yeah. And yep, here we go. That is got to be different. Yep, EMU. And then Repos, programs. Oh, that's the file path. Yeah, that's good. But this needs to be the ROM file. These are going to be useful when we get around to running this code. We're kind of hoping that we'll be able to get it running tonight. All of that's good. So, some of these have CPP extensions, meaning C++, but they're pretty much straight line C code. They do have some object-oriented structure to them, but it's really just the default way in which Windows puts everything out for you. Let's see. Let's just see if it builds, eh? See what happens if we build it. Actually, this... dims. Not sure. The dims or vims? Let's take a look here. Oh, Vim. Well, yes, Vim is a very popular Linux editor, I will say. And when this emulator runs, it had been bringing up Notepad++, and using that as sort of the source code browser. So obviously I'm going to have to use something other than that, because that doesn't run on Linux, or it does, but it's dirt slow. But in this case, I'm trying to use VS Code for all of that infrastructure and tie in to source control, because that's pretty much straightforward, easy, makes things more straightforward and easy for me. So that's why I'm not using Vim right now, but I probably will use it as the source editor for the emulator, if we can get that far. Probably not all of tonight, but let's see. It's worth a try. So let's see. IO stream and con IO. It's like, I don't know what con IO is. Yep, 5108 core.h. That's right there. Why would it not be able to find a file that's right next to it? That seems kind of odd. Let's see. There's no IntelliSense set up here. Well, obviously Windows.h is not going to work there. So let's put Windows.h up near the top. And then con IO here. IO stream. These two are my files. Those should be findable. So is music notes and this one. All of that should be findable. I'm not sure why VS Code isn't. Well, I got to tell you, I've been away from Linux and Vim for 20 odd years now. I only go into Linux temporarily to do a few minor things. So this is a lot more straightforward for my current Vim experience level, to put it most straightforwardly. So same kind of thing up here. We want to do pound if def _os Windows, and those two. Apparently there's a Linux version of IO stream, so that's okay. And then this one, this one, this one, and this one are all my files. So if there's also a Linux, yeah, so not really the else. I think that's just the end if right there. Because there's both an IO stream. What don't you like about that? Edit include path setting. Compiler, include path. Workspace folder. Yeah, but those are in the workspace folder. So, that's kind of weird. Workspace folder. What would it be? Workspace folder / one level up. Yeah, one level up, maybe. For example, workspace folder search through all of the subdirectories. Overwriting hotkeys. Don't you love it? Trying to save you from the sounds of coughing. Bit rate slow again. That's kind of strange. All right. Include one. What happened to my line? That's all the subfolders. Does it need to be one folder up? See if that worked. Not so much. Update your include path. Squiggles are disabled for this translation unit. What do you mean? Can't open Windows. I got rid of Windows. This is kind of the... There we go. Got to sort of force it to compile in order to possibly find all of its previous headaches. Oh, I see what it's saying. It's saying inside this one we have Windows.h. So 5108 core.h is Windows.h. And process.h, which apparently is also only a Windows thing. So let's put all these guys up here. And again, def. So that would be why that was complaining. So of course, let me see. Global map file says it can't open it, probably because the slashes are wrong. See, make sure you can see where I'm going here, or where I'm at. Yeah, okay. All right, fdef Windows, we're going to call it that away. You can see why else. And include / oops. Let's see. All right, then get rid of that, then rid of that. Now it doesn't like this still. Cannot open source. Oh, all the other slashes. What the? Why did it do that? Aha, now it found it. All right. Well, that looks like it for the header problems. Go check all our other headers. That one's got no, these shouldn't. Yeah, you shouldn't have any Windows specificities, since they're support libraries, if you will. Yeah. Nope. Nope. All right, good. This is where main is. This is the one we want to compile. Control-Shift-B. Compile. It has all sorts of get top window, so not a surprise there. Really? Oh, we got all sorts of errors. Not surprisingly. Let's see. Hwin does not exist because that's a handle to a window, and we are not doing Windows. Error message is not really visible there. Anyway, you get the idea. Let's see. Really? It says what the line and a column number is, but it doesn't just click to get me there. Or I gotta hover over it. Hover over it long enough for it to do the tooltip. Control click. Okay. There we go. Gotta add a control. All right, so most of these things are because I had to get a hold of the Windows window and tell it that it could receive the kind of VT100 commands that are default in Linux anyway. So at least they're conveniently in the same location. And then we have the same kind of thing here where handle and dword are not defined. So actually, just go to the top of here. Can I do that? Yeah, let's just do it in the top of this file. I don't need all these extra ones open though while I'm at it. So it's hwin, handle, and dword. Back to the top of the file, and this is where we ended up with the first else button, or else case. So that essentially creates a... why does it look like that now? Really? Let's just do it as a pound define. That's just more straightforward anyway. So there we go. So hwin is now a unsigned int. So anywhere in the code elsewhere, it finds hwin, it just replaces it with unsigned int. And handle is going to be the same thing. In fact, so is all of it. URD. All right. Well, that should have gotten rid of those errors. Is not a type. Well, that's what I wanted to do type def for. Oh. Why? Type def, yes. All right. Help me out here if you remember how to do type def offhand. Anyone in stream happen to remember the syntax for type def? No? Going once, going twice. All right. Well, for that case, we shall use our ever so famously useful. Oop. Weird. There we go. This is the kind of thing we want ChatGPT to tell us. Basically, any kind of reference question that we can ask, that's a good use of ChatGPT. You don't want it to, you don't want to ask questions that might get you killed. But let's see. What is the syntax of a type def in C? Let's just see what it comes back with. Type def, existing type, new type. Oh, I had them backwards. That's why. So it should have been existing type, new type. See, that's nice. That's the kind of useful thing I need out of ChatGPT. All right. So it was just a matter of saying type def unsigned int a twinned. And of course, where would we be in the C language if we didn't require some semicolons? Right? There we go. Now it behaves, right? Yes? No, you're still got a squiggle? What's your problem? It is not a type. It is now. But I think it just doesn't really understand things completely unless you tell it to rebuild. Then it gets a better idea. So there you go. No more complaints there. Let's see. Where's our first complaint? Long ago, I learned in the C language and C compilers, you always debug the first problem first, because in a lot of cases, the first problem will cause a cascade of problems. So if you start at the bottom, actually, let's go ahead and crash that so that we can get a fresh list of wrong things. There we go. Let's see. Oh, create semaphore. That's going to be a problem. That's going to be a headache. Let's see. In this case, let's go ahead and fix some of the easier things. Unsigned uint should be a data type 2. So there may be previous or unsigned int is uint. There's probably an include file library for all of these alternate type names because people got tired of typing unsigned int, so they just made it capital uint. Clear that. Build in. Let's see. Create semaphore. That's going to be a pain in the arse. How about sleep? Sleep should not be so difficult to fix. All right. So probably less than sleep, lower sleep. No. Maybe micro sleep. No. All right. Back to the chat. Help me, ChatGPT. You're my only hope. What is the sleep seconds function in CTI in Linux? Yeah, yes, it's lower sleep. Lowercase sleep, but I need to include unisted. Let's grab unisted. I guess it's universal standard or something like that. Got a car driving by with some crazy sounds going on. And so we need to include Unisted there. There we go. And that will fix the sleep problem. But is it a sleep per second or sleep in microseconds? Those are two very different things. Yeah, unsigned in seconds. That is not what I wanted. I actually need sleep in microseconds. Let me guess, it's going to be U seconds. Yes, it's U seconds. Or U sleep. Or micro sleep. Pretty straightforward, you ask me. So, yeah, we want to micro sleep 10 microseconds. We don't want to sleep 10 whole seconds. That would make for a very slow program. Build again. The U sleep problem went away. Let's see, it says errors. You don't give me an error count. You don't say you got 55 errors and now you've only got 40. I got 99 errors. That ain't one of them. Wait for single object. Interesting that that's not a complaint. Really? So create semaphore isn't correct, but wait for oh no, there it is. There's a complaint for wait for single object. There's our other sleep call. I'll make that into U sleep. Let's see. Release a semaphore. Infinite is not there, but we'll deal with that when we deal with the wait for single object. Maybe put the console in a slightly different place. I'm covering up some of the important details, it looks like. Let's see. There's a beep function. Let's see. This was all about the musical notes. Well, let's see if Linux got a beep function. The Linux beep function. Oh, with the bell. That's useless. I want to go down. I want to put a sleep beep in frequency and duration. Let's see. Oh, here we go. Ugh, you gotta be kidding me. I'm gonna have to create my whole actual beep function here. And well, it thinks it's very confident that we are going to be able to create this beep function. Well, let's go ahead and fix it now. Why not? We'll see if it works later. See, we get all of those guys into our and back up here. We have all these includes our Linux solution. Then where do we want to create the beep function? Can I search the whole project? Find in files, as it were. Yes, find in files. Let's see all the places I said beep. Apparently only twice. So since I only did it, I'm only calling it from this library, this function. Since I'm only calling beep from this file, I can go ahead and include the beep function in this file. No needing to make it separate, if you will. So let's see, where's a good place for the beep function? Usually best to put these things near the top when they're used everywhere else. Here's our cue that we got GPT to write for us back in the day. All right. Oh, probably should have put that in there too. I guess. It doesn't have to be. No, it does have to be because we don't need it when we're in Windows mode. So there's no point in including it unless we are in Linux mode. All right. Down here to just before our cue. And there's our beep function. Honest, it'll work. It'll work on the first try. And we'll make it capital beep. Right. Got a bunch of excess lines here. I don't know why they included all of those. Code readability, I guess. But there we go. There's our substitute beep function. And again, since we only using this in Linux, it's if not deft _OS Windows. Do we include our own custom beep? All right. That seems to be a fix for the beep function. See if everything builds. Uh-oh. Oh, really? You just do that. Didn't know I could do that. I accidentally hit Control-Shift-N, and it created a new instance of Visual Studio for me. Or, yeah, Visual Studio Code. This is what I was trying to do earlier, but it wouldn't just run. All right. Control-Shift-B for build. That button. All right. Still no. We got create semaphore, the wait for the semaphore. We'll get to all those in a minute. Keyboard thread, LP void. Well, LP void is a long pointer that's a void pointer, which would be null. So, same kind of thing here. Type def. Void pointer, LP void. Rid of that problem. You'll see we just get rid of a problem, try the build again. Eventually we get no errors. Or so goes the theory. Let's see, a lot of the rest of this is going to be what? Another sleep. Oh, that's in the other thread, so you sleep. So while we're running the debugger, when we go single step, what would happen is I would spawn using this command that other editor and tell it what phone number. Tell it what phone number to call. No. Spawn the editor, in this case, Notepad++, and then tell it what. I'm not on the. What's a happening? Looks clear on the broadcast side.
4 people are watching. Can anybody hear?
Send a text if you can hear me. Can you hear me?
You said can yo.
Yeah, close enough. Can yo hear me?
You in my headphones.
What in the world is that about?
Oh. Well, somebody can hear you. All right, it's just me.
All right. Well, I don't know why that'd be. Did you accidentally mute me?
No.
Well, I don't know. As long as somebody can say they can hear
Alright,
me, I'll
cool.
keep it going. So yeah, what was happening was I'd spawn the editor and I'd sleep for 100 milliseconds and then try and get my foreground window back. I don't know how much of that I'm going to have to worry about. Or worse, I might have to write my own little debug window to show the code while you step through it and stuff. We'll see. Oh, thank you. So let's get back to where I can see myself. I know I'm kind of overlapping. Anybody care if I'm overlapping the error codes a little bit? I could certainly get rid of my pretty little face, I suppose. Let's see. Should have made that a hotkey anyway. Oop, there we go. I don't think you need to see me just sitting around scratching my nose, right? So, you sleep and get foreground window, and this pretty much this whole section is going to change probably. So, let's see. We certainly need to do all this still in Windows. So this whole section of code if Windows. And we do get foreground window and shell execute A and string copy this and that. And that's all to spawn the editor. And then we just sit there spinning, attempting to get the foreground, get the focus back to the emulator. And then there we go. So we'll substitute that at some point with bringing up some other editor so that we can single step. But the first goal is to get the emulator operational, and that's going to be the first thing. All right. Let's see what else we got. Get console window exit process. Wait for single object. What? String compare. Last file open. That is string compare case insensitive. Probably doesn't need the underscore in Linux. Let's see if I just delete the underscore, does it find it? Nope, still doesn't find it. Or it's in some other in yet another header that I have not yet included. So what I'm going to do is I am going to capitalize this string ICMP, stricmp. And in doing so, we will effectively, do I want to do that? I was going to turn it into a macro defined differently for each operating system, but you know, ideally we find one unified version. It wouldn't be a macro though, it would be a, well, it would be a macro. It would just be one parameter macro. What do we call it? Is it only 2 entries? Yeah, I guess it's only 2 entries, so that's not too bad. All right. So up here, we will now define string compare to underscore string compare and x comma 7, x comma y, x comma y, And that should do it for that. And then we got to figure out what the Linux version is. And like I said, it's probably just not including the correct header. So nope, no auto suggestions for me. What is the case insensitive compare string function in Linux or the C standard library? Let's ask the chatty. Is the compare function in the standard lib? There is no built-in function. Let me create one for you. String case compare basically converts all the characters to lower first. You know, there was I'm gonna bring my face back for this because I think I'll make this into a little, clip this into a short. Okay, so there was just this whole Twitter thread about you shouldn't use S1 and S2 and all this kind of thing. You should use function variable names with reasonable names. And while that's true, this is a pretty straightforward function where S1 and S2 and C1 and C2 are pretty usable, right? Return to lower department. Oh, there's a secondary return there. All right. Yeah. Looks like it'll work. Nag is that. Nag this thing. Looks like we might need ctype.h. Don't think I've included that yet. And actually, right? I mean, it's my code instead of a built-in one, but it should work in either OS. So since we're coding around the different libraries, but we might need ctype. So we can go ahead and close my face again. All right, let's go ahead and grab that function. Go back over here. And I'm not going to do the string compare thing. Oh, sorry. Sorry about that. I actually have a mechanical mute button right here. All right, then. Let me know in the chat if I ever disappear and you can't hear me. So there we go. We've got that, and that, and that, and that, and that, and that. So just where we added our other function for beep, we're going to create our own function. Me and ChatGPT are going to create our own function. And that is going to be called the uppercase. I don't know either. Wife can't hear me on her side. We may take a break here in a second and I'll see about all that. But coding conventions is such that you shouldn't use capitals for your function names, and I can probably just use E because, well, no, that's gonna stomp on the Windows version. How about string in compare? That sound good? Go with that. Now that should work for either operating system, so we can just leave that in there generically. Let's see, where was the line that called it? There's the line that called it. Which has moved around because we've added lines. Another reason why we should... There we go. Another reason why we should rebuild often. All right. My stream bitrate keeps crashing. Don't understand what that is. I'm wired network. I know I am trying to do full resolution. De-resolution. Maybe that's why. All right. So let's get back to there. All right. Rid of that. That was annoying. Okay. Let's see. Where's our errors again? We got our semaphore things. We'll come back to those. Exit process. Exit process. I'm not even sure why that's there. Restore the original way on the way out. That had to do with... Yeah, see you next time. Da-da-da. I'm thinking that's all just Windows specific, so... Yes, Windows. Pretty sure all I need is a return to quit generally. In the case of Linux. So those two aren't really needed in Linux. Right. Okay, build again, see where we're at. Getting there, getting there. Program path. Yeah, that's a... What's all that then? 12U unsigned int. Not even sure what that error is trying to tell me just now. Oh, unsigned, long unsigned int. And then I'm giving it unsigned int in the type character. So it's complaining that I'm mismatching my types in what I'm printing versus what I'm telling it to print. The old underscore get chi versus get c. Keyboard hit. So yeah, so in, is it? I don't seem to have a, it may just be missing the headers, but that's all the semaphore stuff. All right. Keyboard hit. So the way this program's operating is there's two threads. Let me come back here. The way the program operates is there's two threads. One's actually running the virtual processor in the background. The other one is periodically checking on the contents of the, or the state of the virtual processor, and then printing out on screen all of the registers and all like that. If you want to see it in action, back when I had a Windows machine, you can check out the playlist. But so because of that, I wanted a way to check if somebody had pressed a key on the keyboard without waiting for them to press a key on the keyboard. Because otherwise that would just freeze my display updates. Now, I may have to make a whole third thread to wait on keyboard events. I don't know yet. But, because get C, I think, actually waits for, oh, you don't see that. But get C waits for a character versus get CH, which is an old way of getting a character from the keyboard. And actually, it's KB hit, which was would tell you whether or not there was a key waiting. Well, geez, this is all run off of function keys too, so God knows how that's gonna be. Durfty. All right. Lots of extra errors. Let's see. Program path. When the main program starts and goes and finds the program path, it gets rid of the program name and then uses that as the location for which it's looking for the ROM files. So the processor is a finite state machine that operates off of a number of ROM files. Those ROM files are in the same folder as the executable, or they are expected to be anyway. So let's see. This program pointer was a Windows specific thing. So I think argv0 is the name. If I remember right, argv0 is the name of the program you're executing. Now it's not going to contain the whole path. It's just going to be the path of the program that you executed. So if your program's in the path, if it's findable, then the argv0 will just be the what you typed in, the name of the program. And if you used a relative path to run the program, it'll be that relative path. I don't think it'll be the full absolute path. And that's what I want, is the full absolute path. So we may fix that with an example program. Let's see. Let's just do that with an example program, and we'll let chat figure it out for us. Let's see. Come here, Mr. Chatty. Write an example program in C that gets the full path to the name of the program that is running. For sure, read link. Blah, 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 blah. Oh, that's convenient. Linux proc self exe. What do you know? That's even more straightforward. Full path of program. So, read link of that. I have to double check. My program file path equals program path. And there's program path. That's the array. So we do just a string copy here. And then we subtract out the... Actually, let's go ahead and do that. We'll create a new one. File. I don't know if it'll let me do it this straightforward way or not. Select a language. All right. Go back over to the chatness. Just copy that code. Let's see if no build task. Configure build task. Blah, blah, blah. Annoying. I suppose I could just save the file and go to the command line, right? Must live in command line. Not allowed to use IDE. Welcome to Linux. Well, we're going to assume that it does the full path, including the executable name. And we'll need to do that at that. I suppose we'll have to say error if it doesn't work. And then, of course, we are doing this if S Windows and file path equals program path. Readlink proc path into program path, size of program path length. Oh, we don't need to print it. We can p error. Sure. We'll p error and exit the program if we can't get the name, the path to it. That sounds like a reasonable thing to do. In that. See, I would never have thought offhand, oh, I can just, get the read link of proc/self/executable and it be the name of the program. I was expecting it to be argv0, which it may well be, but this is, conveniently unified. Yeah, that all looks legit. Build again. Is that a warning? Yeah, warnings. We're not going to worry about warnings yet. Let's just manage the errors and then hopefully that'll keep us going. Again, semaphore, da 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 da. Release semaphore, wait for semaphore. Word hit, Gitchy. Those are warnings. Wait for SQL get console window. So that is, I think this whole segment of get console window is really just to do this. Yeah. This is just to turn on the virtual terminal processing, which turns on the processing of the VT codes. I might not even have to do it anymore in Windows, but I did originally in order to get it to behave. So, and I had to save off the original mode. And pretty much this whole block should be only a Windows thing. Get console mode, complain if we can't. Save it, set the console mode. And then I supposedly could set the size of the window, but that failed. So yeah, these next two printfs are actually clearing the screen and such. And those will be universal. Error dir indif. All right, save that, build again, reduce our error messages. Let's see. Oh, let's make sure we're not looking at previous build error messages. Hate when that happens. All right, semaphore stuff, keyboard hit stuff, semaphore stuff, warning, infinite, that's part of the semaphore stuff. Create thread, that's like, really? It didn't complain about create thread. Let's see where that is. No, it did complain about create thread. So yeah. Boy, talking about bringing back memories. You know, fork and exec was essentially the way you spawn, or was 30 years ago, the way you would spawn a new thread in Linux. Maybe it still is. I don't know. We'll have to dig into that, but oh, not too far off. Let's see. Warning. Wait for single object. So now the main thing, because we're going to have to use this in both, is we have to have a way to wait to know that the keyboard was hit. Let's just check if the non-underscore version helps. No, it does not. So we need to know whether or not or how the keyboard is hit, and then if it is hit, we can get a character. And get C actually should work as well. I'm not sure if that would work in Windows too. So let's call this my get C and my keyboard hit, and we will deal with them as macros up top. Well, pound define since there's no parameters to pass. So we need to create a my keyboard hit and a my get G somewhere up in here. That's probably the best place for it. I could also, here I am optimizing already. I don't know why I need this separate OS Windows to pound if I can just put it up in this one. Unify those two. But while we're at it, we will define my keyboard hit, which should be all caps, I'll grant you, to underscore KB hit. And yeah, that should be my KB hit. And then find my get ch. Under Windows, it is get ch. And then go back to where keyboard hit it was. That my keyboard hit. And I get ch as capitals. And then we will need to define a version of them for Linux. So, and since we're actually so it's really the keep, I mean, the KB hit function is what determines whether or not there's a character waiting. So we may be able to get rid of, we may be able to just use git C for the Linux side, but let us ask the chatness. All right. What function will indicate that there is a key press waiting in Linux in C? What do you mean I can use a KB hit function? Be that way. Let me guess. I just didn't have term iOS installed, right? That's why. So they do have KB hit. I was wondering about that. So most of these functions where Windows says, oh, that's deprecated, use underscore blah, blah, blah. It's, in a lot of cases, it's this. So we'll take those two include files. But since I still have to define it with the underscore for Windows to not complain, we'll leave the macro in place. And let's see, we got select and term OS. And then we'll define these guys as the non-underscore versions of themselves. I'm betting git ch exists too. Now, let's see. Build. Let's see. Looks like we're getting down to where we're only dealing with warnings and semaphores. Wait for single object. Oh, nope. I don't like. Did you mean? Me. Oh. Let's see. Control click. My Gitchy. Oh, here. Set my git ch. Well, apparently it is not defined, but that should be doable. Really? KB hit was not declared in the scope. Why not? Did I miss one of the includes from the chat? Standard IO? Am I not including standard IO? Yeah, standard IO. All in unistandard twice. Need that. Standard IO. Select unistandard term IO.is. That is included before I define it. What is it not liking about that? Let's see. Oh. Gitc takes a parameter of a file pointer. And then that's not the one I want, is it? I don't want gitc because I don't have a file. I mean, I'd probably do it with standard in or something to that effect, but doesn't like the KB hit though. What am I missing? Some sort of case sensitive BS, probably. Not KB hit. Oh, that's why. Chat went and created a KB hit function for me. So we need this whole function. That's what I'm missing. It isn't actually in term iOS. So again, my KB hit is KB hit. There's my special string compare. There's my custom beep function. There's our custom KB hit function. And that is only included if we're not defining windows. Yes, that's good. Let's see what else we got going. Well, earlier I thought I didn't need to do this differentive include file down here because I can include that. And that here. And then I can get rid of this second OS guard, for lack of a better term. Right. Not declared in this scope. Int KB hit. Now let me guess. That's because it is being forward defined. So int KB hit void. Let's go ahead and throw the prototype for that up top too. I should, I think I can do that. Let's see what happens. And I got rid of the squiggles. All right, so we prototype KB hit up here so that this passes. And then we include it down here. Only if we're dealing with OS or non-Windows functions. And mind you, we don't know if these functions work yet. We're just trusting chat for now. And let's see what else we got going. Still having trouble with the stream throughput. I'll have to figure that out somewhere along the line. All right. So far, ChatGPT's been reasonably helpful. Oh, Gitsy, that's what we were at. She was not friendly. So, and you know, maybe the KB hit exists, but and then ChatGPT just created a copy for me. I don't know. Let's see. What is the Linux version of gitch? See if it figures that out from that. Git char. Close enough. Or we'll see if it's close enough. All right. That looks like that's good. Build again for the 50th time. This git top window is probably also a Windows specific thing. Oh yeah, create thread and get top window. That's probably gonna be a fork and exec. But So, I guess KB thread is the function that more or less just spins on itself, getting keys, but then it also renders the state of everything. So it is not a small function. But let's see. Let's get Windows. We got a bunch of start thread, bunch of semaphore warnings. What else? Any other low-hanging fruit here? Okay. Yeah. Oh, look, there's an error in the code. Not surprisingly, there's some error in the code that ChatGPT created. How convenient. Cannot convert this flag to that flag. Ah, bother. Doesn't like that. Nah. You lying ChatGPT, I tell you. This is just a work honest. See what the actual. Alright. Saved flags is a TCF or TC flag type. Pointer, aka unsigned int. Cannot convert to term iOS pointer, because that is what getTest attribute expects. Cast it and forget it. Which is basically saying, we don't need no freaking type checking. Oh, that's not what I wanted. We're going to call it a term iOS pointer. Then term iOS, new flags equals save flags. Save flags. Why is that not just a term iOS pointer or term iOS block? The last parameter is also a term iOS pointer. Set terminal to non-blocking mode. And I tell you what, we will do. We will skip the lines that are complaining right now until we get a chance to actually run this. And then once we're running, we can try and debug what it doesn't like about these things. Because we need to get to final compilation before we can actually start dealing with the individual problems here. In fact, I don't know why I did that. We can just comment out that. That's why I did it, because I don't want to comment out the structure definition. I just want to comment out it's equaling some other, clearly not the same structure. So that should at least get rid of those complaints for now. And then once we are debugging, we can start actually figuring out what works and what doesn't work. Let's see. Well, let's get rid of the semaphore and the thread stuff. Finally looking at the semaphore stuff, I tell you. All right. Only took 2 hours, right? All right. And then let's just go to create semaphore. Q semaphore, which is a type handle, which is an unsigned int. And we create semaphore. So semaphore creation in Linux is probably like POSIX. So write a use example for Linux. I guess I should have specified in C, but it looks like it knows I'm doing everything in C. Blah, 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 explaining a bunch of extra stuff. Oh, at least here it gave the command line build example. All right. So SIMT is the sim type. You know, come to think of it, now that I'm looking at this, we're going to have to change the semaphore type. Or we're going to have to change the type of the, so here we go. Our Q pointer semaphore is a handle in Windows. That's going to have to become sim type, sim underscore type. And, well, all the input output Q stuff is in here. There's the actual definition for that matter. What do you think? Should I actually bother to encapsulate this send and receive queue as a separate object, or at least a separate file? Maybe. Maybe not. Tell you what, I need to take a break. Bathroom break real quick. And so we will go back to the lobby for a moment, and we'll do with all that and check on the audio and so forth, and be back in 5 or less. All right. Yeah. Be back in 5. See ya. And we're back. Hopefully we're back. All right, that was quick. So somehow her tab got muted. Not sure how. Things just weirdly happen sometime. So where we were at was I had created this semaphore here using a Windows handle. And it needs to be a SIMT, but I really probably, you know, for out of, what do you call? Good programming practice would be to take this whole queue with semaphores functionality, the is empty, is full, etc., and put it into a separate source file. There's the DQ function. But since I'm only using it in this file between these two threads, it was just easy. And actually, this is, interestingly, this function was also, or this code for the byte queue was created by ChatGPT as well, although I added the semaphore functionality later, and that one, it doesn't use angle bracket F and angle bracket R. It actually uses reasonable names. So, all right. Yeah, we're just gonna do it in here. So again, with the ever so useful ifdef OS Windows. You can hear me, right? Yeah, okay, good. It looks like you can. We're gonna make that a handle. Else, we're going to make it sim type. You can, I think you've begun to see already why I'm not using just Vim as an editor, because being able to just click on an error and jump to it and all that kind of thing, and you know, there's some amount of helpfulness in the VS Code autocomplete and all that kind of thing. Except I don't have SIMT type, because let me guess, I didn't include that file. Let's see. Yeah, so conveniently it's called semaphore.h. I'm probably going to need pthread.h as well, because I think this example, yeah, maybe. It did a producer consumer. Yeah, and then it created two separate threads for it, which is the other thing we're going to do, is create threads. I got sim and knit here going on. That's kind of annoying. Sim and knit, empty and full. Pthread mutex in it, even. Ugh, that looks complicated compared to the way Windows did it. It seems complicated, but at least we have the examples already. So pthread and semaphore.h, and back up in our header. Pthread and semaphore.h, and check on the status. Still having stream health warnings. Good, but not excellent. I'm hoping it's clear enough in the. I'm like, is all of this text readable? Let's see. Let me know if the text is not readable or becomes unreadable, probably because of the stream problems. Trying to keep it zoomed in reasonably well. All right. I think we can go back over here, and like I said, I don't think we need my pretty face up there all the time. All right. So that's our semaphore. issue. Now, I haven't seen yet whether or not VS Code just builds all of these CPV files that it finds in this folder, or if I have to go build them separately somehow, and how it does the linkage. I think that's all going to be in tasks. I'm probably going to have to do something special to the tasks JSON to, say, compile all of these files and then link them all together. In the assembler, it was a single file, so it was a much more straightforward program. All right. So I just say create semaphore, right? That's all I had to do in Windows. But apparently in the Linux version, you have to do a number of initializations. Why is it doing a mutex and a semaphore? It's crazy. What? An empty and a full semaphore too. That seems a bit excessive. I don't think I'm going to need the mutex stuff. I would think so. But if we have to, we'll, build the example, see how the example plays, and bring over what's needed from there. Modify the example. It's easier to cut out parts of the example than it is to constantly add and change to the main program. But it looks like, at the very least, I need a sim init function. Empty, 0, and buffer size. Where is buffer size defined in this? That's an int buffer. Okay. I'm using a character buffer, but I really think this is much consuming item. Mutex unlock. Oh, I see what it's doing. Huh. That's kind of weird. I mean, I say weird. Generally, I've only needed a semaphore. So in other words, I got 2 threads, right? Let's put this up here right quick. So when you have 2 threads and they're both talking to the same block of data, generally you would create a semaphore that says, essentially, thread 1 says, give me the semaphore. And if thread 2 does not have the semaphore, then thread 1 gets it. Now, if anytime thread 2 asks for the semaphore, it's forced to wait until thread 1 is done. And in doing so, you would grab the semaphore, make some change over the shared data, and then release the semaphore. And as soon as the semaphore is released, then thread 2 would be able to get it and be able to do whatever it wants to do with that data, right? And that's the general use. I'm not sure why they're using a mutex as well for mutex is mutual exclusion, lock and unlock. And I'm not sure if that's an absolute necessity or not. I guess we'll see. As we will always see, right? Look, this example even included a uSleep function for us. So let's see. We do have to do sim init. Sim init, pointer to the semaphore, and the buffer size. Why would I need to include the buffer size? Let's do a separate one here. Just look up for the man page for sim init. Initialize an unnamed semaphore. Da, 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 is right, da, da. P shared is argument indicates that this be shared between the threads of the process or between processes. Shared between the threads of a process. Okay. Hmm. All right. I think I can get away then with the 0.0 version. And get back up to the top here. All right. Keyboard hit function. Create our semaphore here. Initialize the queue. I didn't like if-def. Why don't you like if-def? Queue pointer semaphore. And I guess that's address of queue pointer semaphore for that matter. And it's probably all I need to initialize it. I guess we'll see if we go. Needing to do the mutex as well. But there's our semaphore init. And we have, let's clear that out. Get our new set of errors. Get top window. I thought I'd already covered that problem. No, I did not, because that's the thread create. And release semaphore, wait for semaphore. Warning, warning, warning. Wait for single object. Wait for single object. All right. So wait for single object is essentially wait on the semaphore. In the chat version of that, it appears that it is called sim wait. What do you know? All right. So wait for single object becomes sim wait. Again with our windows. Oh, okay. I didn't think I had the mic down near my mouth. And that's our output queue. Oh, I forgot that I did two queues, one for input and one for output. But the input queue had exactly one base in it, so it was kind of redundant, if I remember correctly. Let's wait for semaphore. And there. And then we do a release semaphore. Let me guess, what's release semaphore in Linux world? Sim post. Oh, hmm. Hmm. Maybe I'm thinking about this wrong, and maybe I should be using just the mutex. Or does it not wait? I might have to do a little more research on semaphores and how they differ between the two, and also maybe not using the mutex in Linux is why the queue occasionally gets overfilled. But we may have to do some more research on that. Wait for the threads to finish, which they won't. Nice comment there, chat. Hmm. Do sim post empty. Sim post full. I thought I could get away with the single semaphore. Yeah, I really thought I only needed the one semaphore. For simplicity's sake, we're gonna try it out with the one semaphore scheme like I currently have, and maybe that'll work and maybe that won't, but that'll be a problem for runtime. We're just trying to get it all to compile yet. So, okay, thank you very much. Dev OS Windows. Release the semaphore. Otherwise, post our semaphore. Wait and then post. It seems like it might be just a different scheme of semaphores in general in Linux versus oh, and that's supposed to be a address of, most likely. Yeah. And like I said, we shall see if that is significantly different behavior or significantly different architecture for Linux semaphores versus Windows semaphores. I know in the embedded systems, you could just get away with using the single semaphore like I've been doing for Windows so far. So, again, problems for runtime, not compile time. And then the input port, same kind of thing. I should have defined both the input port and the output port, right? Port right. Doodle-doo. Initialize queue. Oh, I see. This function is used for both the input and output queues. That's why there's only one copy of that. And down here, let's go ahead and block and copy this line that I've been using over and over again. And do the same for here. Wait for this. Oh, yeah. Sometimes. Sometimes you design something in a fashion that you weren't really totally settled on, and it worked well enough for now, kind of a thing. We'll deal with doing it correctly later. Compile now, fix it later. So we need a wait for this one. Then wait, input Q, no such thing as infinite. Or rather, it waits infinitely, I guess. And post. I might have to look up what the parameter here is in release semaphore, this one. But yeah, semaphores may just be behaving differently between the two OSs. Though I don't remember it being like that for POSIX. All right. Get rid of all of those problems. Control-Shift-Build. Let's see what else we got. Oh, gotta do these fixes in the other thread. There we go. And then here it is. Oh, dot, sorry. And all that nice autocomplete is kind of, I don't know. Does all that, do we get those kinds of autocompletes in Vim nowadays or not? Because that certainly is part of why I like these IDEs. And here's our release side. FDEF Windows. What was it called? Sim post. Output Q. Oh, really? Output Q. Dot semaphore. All right. It should be all the semaphore fiddling. I think that's going to be all semaphore fiddling. Then we just have create window. And all these warnings, we'll deal with warnings later. Oh, another wait for single object. Why is this? Oh, input and output queues. That's right. FDEF OS Windows. This is, yeah, input queue. Q dot semaphore. Diff. Yeah. I'm doing so little between these semaphore wait and semaphore post. that I could just do the whole OS guard or OS pound if over the whole collection, but probably not the greatest idea to collect too much together. I seem to be having extreme slowing. Buffering. Looks like it. Looks like it's buffering. Maybe we minimize this guy and that'll save it. At least I'll see where I'm at. At least on my side, I see where I'm at. Alright. Same thing, release semaphore. Close, destroy, get value, init, open post, wait. Sim open and close might be the more appropriate things. They kind of sound like they'd be the appropriate things. Q.semaphore. I'll have to read up on that. Let's get through compilation first. I think we're almost there. We're almost going to have a clean compile. We just need to spawn the task correctly. And then deal with the warnings. Alright, so warning. Warning, warning, warning. Warning, warning. Error. Thread routine. On the create thread function. So we're finally dealing with the create thread function. And in our case, we get a handle back. So this is all the Windows version. Do I still have that? Yeah, it's still in the queue. And then, all right, so create thread, get top window stuff. Over here we had a p thread type. So we need a p thread. And we never access the handle after the fact. It just is required for the OS or for the APIs. So is it spinning over there? Am I highlighting prod thread at the moment? Oh. All right. Well, it looked like it had hung up on the streaming. Wasn't sure if it had or not. So we're gonna, what are we gonna call this? We'll call it H, because why not? It's the same as the other one, right? And then that is going to be, oh, it's not equal. Used it passed as a pointer, so pthread H, pthread create. Oh, all right, I can just hear my instructors screaming at me. Okay, we'll call it keyboard thread. Keyboard thread, and I believe the function was named I don't remember. The other thing. Ooh, it's called KB thread. Capital KB thread. So that's the function name. And argument of type unsigned int, blah, 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 blah. Incompatible with voidity void void. Oh, how weird. All right. So we're going to have to redefine the way keyboard thread is defined. Unsigned int pointer. Incompatible with parameter type void void. Right. Well, let's see. You're going to be like that. We're going to have, oh. Can I just grab it from up here somewhere? Nowhere nearby. Oh, well, whatever. Type it again. It's actually better to not type it over and over again because that can introduce errors. Oop. Gonna be void. I don't think I ever used the parameter that's passed to the thread anyway. It was just the example Windows. So that should redefine it for us in a way that is compatible with Linux. Go back to that. And like keyboard thread. Avoid pointer. Not sure what it's complaining about. I just need to force void in there as well. I didn't think so. Let's see how the chat defined its functions. It defined it as a void pointer, with void arg. Well, then we'll steal that pattern. And just change that. There we go. See how that works, right? So much faster than looking up the manual. Let's see. It's no longer RTFM. It's ask the chat. ATC. All right. So that should behave now. And yeah. All right. Are we done with the errors? Let's see if we're done with all errors and we can. Aha, build finished. Except for the compile worked. Now it's sitting here saying undefined reference to this and such function, undefined reference to this and that other function, etc., etc. And these are all the functions that are in the other source files. So we're basically going to have to continue doing this on our other CPP files. Like, let's see if counter 8-bit. Just see if that compiles. Come on, compile for me. It compiled, but it didn't have a reference to main, so it's not a complete program. Let's see. Yeah, there's going to have to set some stuff up for in the build environment here to what did I do for sleep over here? Wait, what? Hmm. Oh. The capital sleep over here was both commented out. So we didn't actually handle capital sleep. We yeah, I guess so. Didn't actually do capital sleep. We actually did micro sleep. But was that compatible with Windows? I'm gonna have to look back at the tape. Check the tape and see what we did with sleep. Because micro sleep I don't know. It's been a little too long already, oddly enough. All right, well, we'll come back to that. Like I said, I still got to check how I put all of these things into, what is this file? IDSL CPP. It does a whole lot of nothing. Add your implementation code here. Well, I imagine this was some example code that I left in here. It doesn't look like I'm actually using it, but let's see if register 16-bit builds. Yeah, it built. Again, clear that. So our 16-bit built, but again, linker issues. So here we are. So the main file, the one that had most of the interactions and most operating system interactions, we managed to get that to a compiled state. Not fully linked because we have to do something probably in settings.json where we combine or actually, is it settings? That's not settings, tasks. So here's the build configuration, right? And it says, is it bin gcc arguments this. I probably have to repeat this multiple times for each of the CPP files. And then see where the linker step is. I don't see a linker step. Build. Huh. I guess you don't really need a linker step if you've only got one object file, right? If you got one source file, then you've got one object file, and one object file can become your executable file without a linker to combine a bunch of other ones. But it's probably something in here. I got to add multiple args, or I don't know what. We'll probably ask chat about that too. But I think that's about where we're going to call it for today. Thanks for joining in, and be for sure. Feel free to like and subscribe and all that fun stuff. Like and subscribe, and join us next time at the randomly announced stream time. Follow us on TwitX, whatever they're calling it now, whatever we call it today. And that's generally where I post upcoming streams and so forth. And we'll be seeing you next time. Thanks.